In general, in machine learning, historical data is compulsory. Previous data is there, then only you can perform the operations of using that data and perform it. But in general, in both supervised and unsupervised, data is compulsory. Previous data should be present. In unsupervised, we are only given with the inputs. So outputs are not there. Means what you are going to predict, what classes or what value that you want to predict is not given there. We are given with the data only, and we have to identify the similarities in all. We have to identify the groups within that, the pattern within that. That's what the application of the data is present. And in order to use that data, we have to use some data processing techniques. Pre-processing techniques are there. That depends. Many are present. I'll not go in detail about it. We'll generally look at for the commonly used clean data with us. I assume that, and based on that, we'll perform the operations. Okay. Then it comes with the machine learning. Okay, so here we apply the machine learning technique. Many clustering methods are available present that we can use. Out of it, 3-4 methods are very commonly used. Now, out of that, the in first part of the session, what I'm showing that will commonly use method, but as key means clustering that will see. And then output of the machine learning is the pattern or rules, which is shown over here, pattern or the rules. And at the end, we are going to do the validation by using business context, like whether the created model is working perfectly or not, that we can see with the help of this particular technique, validations. Like, okay, so this is how unsupervised learning actually does. It does not have the output data. Only input is given, which is identified for the similarity notion, and then the groups are created. So many applications are there in it. We'll go one by one how exactly this technique is used, applied in the real world situation. So the very commonly used unsupervised learning technique is called as clustering. So you might have heard about the terminology already, technical terminology, cluster. Cluster is a group. It's a collection of elements that we generally call as a cluster. So it's an unsupervised learning problem. The main objective is to identify the distinct groups inside it, unique groups, which are called as clusters based on the some notion of similarity in the given data set. Which of the elements inside the data set are similar? Okay, which of the elements are similar, which are not similar? Okay, or like I've given a data of 1,000 elements, and out of it I want to create 5 clusters. So I can make use of a similarity notions idea, and which are similar, next are similar. Like just take an example that I have given the data of students. Okay, students of your whole college. So I'll similarity notion will be like name of the department. So electronics and telecommunication student will be different, computer engineering different, information technology, mechanical engineering. So that is a similarity notion that they carries within it. So based on that, the groups can be formed. Okay, and if you are given a data of single department, like electronics telecommunication department data is given. So according to year, so year can be the similarity. It depends upon the algorithm. Algorithm will find it. On year, the first year students are having one group, another year, next year, like two groups will be formed with the help of that similarity notion that they carry. Similarity notion will be the year. Okay, so that will create a groups within that particular data. Or if you are given the data of single class only, okay, on a single class, so based on maybe gender, will create a group of it. So female student differently, male student differently. Okay, or based on the marks criteria also, that can create a groups of the data. So similarity notion that identified with the help of the your data science algorithm, that is called as the clustering. Okay, and that is done automatically. But there are some technique that it internally uses. How this is actually using, that also we'll see. So actually clustering we have seen across the year, manually also, scientifically also, human has done that. Like anthropology, it's one of the main area where clustering is very perfectly done. So very detailed concept is there. Psychology also, these kind of techniques are very regularly used, and almost in all the areas that we see today, if you want to create a group of something, so we make use of a clustering technique, similarity notion, and based on that we do the operation further. So in case of clustering, there are two commonly used techniques are present, okay, which I mentioned over here. The first method is called as the k-means, which is divisive kind of technique is there, and second is the hierarchical, that is what we call agglomerative kind of technique. Agglomerative clustering we call here, divisive clustering, agglomerative clustering are there. Okay, so they behave differently. When we in this session we see divisive clustering. In next session when I show agglomerative clustering, we'll see the difference between them. How actually the things are differentiated, how they perform the operation separately by using different kind of algorithm. Okay, that I will show. Okay, so remember that. Now let's come with the k-means clustering. So k-means is a very commonly used algorithm which is performing the operations of finding the clusters within it. So some different name is given, like k is present over there, k means, and then clustering technique. So the main objective of k-means algorithm is to organize the data into clusters such that there is high intra-cluster similarity and low inter-cluster similarity. Okay, so whatever data is given to you, inside that particular data, the groups within it are identified. Okay, groups within it are identified, and that groups are used to, means they are created such like that the groups within the groups there is low similarity present, and inside the groups the number of element, whatever 10, 20, 30 are present within that, they are having high intra cluster similarities are present. That criteria is kept in mind. It's not like that in thousands of elements, if I want to create 5 clusters and every cluster contains 200, 200, 200, 200 elements. It's not like that. Maybe one cluster contains 600 element, one contains 50 element, another contains 80 element. So similarity things is common, which is kept in mind, and based on that, the groups are identified. They are created separately. Okay. So in this case, one element, one item will only belong to one cluster. Single cluster is present, and inside that only it will go. It's not like that key element number one present in my data belonging to cluster number two also and four also. Okay, it's not like that. And algorithm is so designed, so simplified, so implemented in way that it will belong to a single cluster only. Remember that. Okay, not several. That is, it generates a specific number of disjoint and non-hierarchical clusters. Disjoint and non-hierarchical cluster. Hierarchical clusters are present, but that is in the agglomerative part. Here we have the divisive category. So these clusters are not available, like which are disjoint, means which are having a common elements within it. Okay. So K-means uses a strategy called as divide and conquer. Okay, you might have heard about in the algorithmic steps. So divide and conquer is a strategy of algorithm by which you divide your algorithm in small parts. Okay, we find a solution separately on these small parts. Okay, and once the whole solution is identified, then we combine it together, and a common solution is given to you. That is what we call as divide and conquer. So this divide and conquer strategy is used by the k means clustering. With the help of that, we create the groups within it. Okay, so the classic example is called as expectation and maximization, the em kind of algorithm which is used over here. Expectation maximization again is a strategy of algorithm there. What is your expectation? Means first step, that is what your output is expecting out of it, and then maximization means the steps involved to perform that particular operation. So first step is maximization, expectation, sorry, and used to identify the expected point associated with the cluster. What is your expectation, what you are expecting as the output from this particular algorithm? Okay, that is what is e, the first part of the particular algorithm there, e. And second is maximization, which is used to improve the estimation of cluster knowledge using the first step. Okay, so what strategies, what criterias we need to apply on that so that your expectation can be achieved, can be reached. The second part of it, that is em kind of algorithm, which is used here in the k-means clustering. Okay, so these two steps are processed repeatedly until the convergence is reached. Okay, so these are the steps which you perform operations with. Let's go in detail, step by step, how it separates it. Okay, see, the left hand side figure is your input, that is your original unclustered data, and the right hand side is the clustered data. So we are given with the data, raw data. So it's just plotted in a two-dimensional plane. It's not compulsory that only 2D, two features should be present inside it. It may contain any number of features in it, 4, 5, 6, 7, 8 also. Okay, so that is why your original unclustered data is present. Which one? It's like that. Okay, so shown all they are in blue color. And now I want to create a group of three, means three clusters I want, three groups I want within it. So after applying the clustering method, clustering technique to it, my output will be something like this. Okay. So here I require three groups within that data. Okay. So this is input data, this is output data. So I require three groups within that data. The first group, which is shown here in green color, so they are having similarity notion. So they are all are similar together by some common properties in it. Okay. The blue is the second group which is present inside it, and the red one, third group. So they are having similarity. So high intra-cluster similarity and low inter-cluster similarity that is present and available in the clustered data. Okay, so in this way the groups are formed. I can create any number of groups within it, but statistically there are two methods present in the KMS clustering. With the help of them, the grouping is easily done. Now remember, you just can think of what to do, why to do this one. Maybe the question will be there in your mind, but remember that this is very useful method most of the time, which you when you have to create the groups, and I want to separate them, just like example I told about the classes. So machine learning can do that. They find the similarity on that and then perform the operation. So your human intervention will be minimized, or no human intervention will be there. Computer algorithm itself will perform the operation of separation the data and cluster it. Okay, like this, which is shown in this particular diagram. Okay, fine. Okay, so which is generalized algorithm that we use, commonly used algorithm. We'll go step by step how this algorithm actually perform the operations. So let's see. Our algorithm works as follows, assuming that we are having inputs like x1, x2, x3, xn, and along with that we have value of k. x1, x2, x3, these are the data, okay, rows or individual data which is present in the form of a collection. So for example, I'm having a data of 1000 students. Okay, so x1 is a single student, x2, x3, x4 till x 1000. That number of students information is present with me, and along with that I'm having a value of k also. Value of k means how many clusters, how many groups you want to create within that. That is what we call as the value of k. Okay, that should be known first, and then only it is possible to create the clusters within it. Okay, so the value of k, it should be given. Even as I told in previous slide also, there are some statistical methods present, graphical methods also present, which are used to find the ideal value of k, means how many groups or clusters are possible within that data. That's also can be done. We'll see that one also, how this perform the operations. Okay, so steps how they are done. Step one, pick k random points as cluster center and called as centroids. So a new terminology, centroid. So as I shown in the previous slide that we are having unclustered data, I want to create three clusters within it. So what I'll do, three random point, almost spaced equally, almost not exactly perfect, almost spaced equally throughout all the data, and they are called as centroid. So centroid number one, centroid number two, centroid number three. The three centroids will be there in it. Okay, and they are almost present at equal distance, not exactly equal, almost consider that. Okay, so three groups, you got three centroids. Centroid means the median of all the element of that particular data. Okay, this is first assumption. Now the second step, assign each xi point to the nearest cluster by calculating its distance to its centroid. Okay, so first element is taken. We'll identify which is the nearest centroid of all three. Okay, for example, I have thousands of entries. Out of that, three centroids I have chosen. And now to apply the clustering, I'll take one by one point. So first point will be taken, and we will calculate distance with the second or with the centroid, sorry, which is the nearest centroid. So three centroids are there, three distance will be there, and which is the nearest one. So in that particular centroid or that particular cluster group, the point will go. Might have heard about the formula called as Euclidean distance formula. So Euclidean distance formula, Manhattan distance formula, or Mahalanobis distance formula. So basically I use the Euclidean distance, which is very commonly used technique by which you can find the distance between two different points by putting a straight line on two-dimensional or multi-dimensional plane. Okay, so that will be used. And By calculating it, we will identify which is the nearest centroid. So when nearest centroid identified, the point will go in that particular cluster. And most important thing is that centroid will change. How? Now centroid will be the average of new point and the centroid. So it will change at the center of it. So find a new cluster center by taking the average of assigned points. So we'll take the average, cluster centroid will change. Okay, as because a cluster is there inside it, a point will be there in the cluster. Centroid means it is always at the center of all. Okay, at the center of all. That's why centroid will change. And now perform the same operation for again n number of times. Repeat step 2, step 3 until none of the cluster assignment changes. I'll show you that one, how actually the operations are performed. See the diagram. So just as I told, it is EM kind of algorithm present there, estimation and maximization. So sorry, expectation and maximization. So here, check out the left hand side diagram over here, this one. Here we have, for example, some n number of points present here. You can see this one. Okay, so at most 18 points are present inside it. 18, 19, something. Okay, here. And they are plotted on a two-dimensional plane. So two-dimensional plane is easy to understand. Basically, n-dimensional planes are there. If number of inputs given to a data set are more, features are more, that case it is n-dimensional space is required. So 2D is visualization is easy to understand. That's why 2D visualization is shown over here. Okay. So let's see. So for example, these are some more 20 different points are present. They are plotted on it. In expectation phase, as I told, the three random points are taken centroid. Okay. So for example, C1 is here, first centroid. Then this is second centroid, and this is third centroid. Okay. So C1, C2, C3. Three different points are taken in that data, which we consider them as centroids. Okay. Centroids are called as the center points of the respective clusters. Okay, like this. And after this, we'll take one by one point in that particular cluster, one by one. First point, and second point, third point, like into the respective cluster. So let's check it out. For example, here this point is taken. So from this point, which is the nearest clusters, you can identify with the help of a Euclidean distance formulas. So let's see. So here, if you consider the distance of this point, C2 distance, C3 distance, and C1 distance. So C1 is the nearest cluster, so it will go in that particular group. And then centroid will change. This one C2, this one C3, this one C3, this one C2. Okay, so can identify the centroid positions. Then this one C2, this one C1, then again C3, again C2, again C2, C1, C3, like. And as soon as the points will go inside the cluster, the centroid will change by making the average of previously assigned values within it. Okay, average of all the previous assigned values will be there. This is the expectation. So unless and until all points are not over, operations are getting complete. 1, 2, 3, 4. And as I shown here in two-dimensional plane, x1 is the first feature, first input, x2 is the second feature, second input. Likewise, x3, x4, x5 features can be present. Okay, columns basically when you're giving a data as input, that features are present, and then we can have a multi-dimensional plane, and with the help of again distance formula, we can calculate the distance and get acquired with the points within the respective clusters. When all the points in the data are over, completed, then at the end, what do we have? Maximization. So centroid will be placed at the center place, at the center place of location of your data set. So okay, the maximization part here now. In case of maximization, again, see, this was your initial centroid, C1, C2, C3, correct. And as you're starting getting one by one element within it, so your centroid will get change, like C1, C2, and C3. C1, C2, and C3. Three different points are present in it, C1, C2, C3, and which are the final recalculated centroids. Okay, these are final and recalculated centroids are there. Okay, which are calculated at the end, maximized data is present. These centroids are placed at a place where all other points are uh, near to that particular centroids. Okay, there is having high intra-cluster similarity and low inter-cluster similarity is there, like it. So this is what we call as k-means clustering. You need to specify the value of k in advance, how many number of clusters groups you want. Okay, and once value is given, then according centroids are done, and then we'll get one by one element within it. Okay, so this is called as k-means clustering algorithm, and how the workflow is there. This is shown by the respective diagram. You can just check it out. Now, what are the limitations of these kind of algorithms are? So why to use and why not to use? Like, so let's focus on limitation. Advantages are many. The first is k-means clusters need the number of clusters to be specified in advance. Number of cluster need to specify in advance, means before actually performing the operation, you have to specify the number of clusters. K, value of k that we call. Generally, directly, if I know that I want 5 clusters, 10 clusters, 6 clusters, like, so I can directly assign the value. But by statistical method also you can find there are two ways are there by which we can identify the ideal value of k in this case, and that is called as first method we call as the elbow method, by which you can identify ideal value of k, and the second value is called as the Silhouette method. With the help of that, the ideal value of k can also be identified. Okay, so with this we can find the value of k. Second, k means having a problem when clusters are in differing size, density, and non-globular shape. So, like, one feature is having high values, one feature is having very low values, another feature again different kind of values. So in that case, it may create the problem. Okay, like magnitude of the data can affect the output of your algorithm. Magnitude of the data can affect the output of the algorithm. That is possible. So to overcome that particular problem, there are two different phases data analytics algorithm can use. First, we can either feature scale the data by which the standard deviation of all the data can be kept one. And second method, we can use min max normalization. With the help of that, the ranges of all the features can be in the same range, so that effect of them in the output will be same. Okay, so this technique can be applied when you are having different sizes, different densities, different magnitudes of the data present, and it is affecting the output finally for creation of the uh, clusters. Like, okay, and the last is presence of outlier can skew the result. Basically, see, I told already what is outlier. Outlier is actually the element which does not follow the criteria of the crowd. Okay, outlier. Like, just an example. Again, come with the class in your class, almost every student is getting marks from 60 to 70. Okay, 60 to 70 something, and one student has got 85%. So he is outlier, does not follow the criteria of the crowd, so he is outlier. Like, or the ages of all the students starting from 19 to 22, minimum 19, maximum 22, and one student age is 35. So that is outlier. Remember, so which does not follow the criteria of the crowd, they are called as the outlier. So outlier detection, outliers are, and that may skew the result. Some point is there which is far away from the original data set. Okay, so in that case, where in which particular point you have to make it, so it may skew the results also. And one more thing I just want to mention here, that how k-means is also one of the method that we can identify the outliers. It's an outlier detection technique also. It is used by many data scientists. Even I have also used one to find the outliers with the help of the k-means detection. And how it is done actually, see, it shows that particular points far away from the, when you plot it on the two-dimensional plane, far away from the original crowd. So remove that. So it create direct different clusters over there. So that cluster contain 5 points. So delete that cluster directly. So all the outliers present inside that data will get removed. Outlier detection removal, that is also possible, but it's a limitation that if you're basically focusing on the clustering technique only, and some points are present which are outliers, so that kind of problem may arise, may occur. Yeah. So let's see some of the applications where we can apply the k-means clustering kind of algorithm. So it's used for many applications. Some of them are just mentioned here. Okay, the first is image segmentation. Image segmentation. Okay, so many of you are from electronic telecommunication branch might be knowing image segmentation very commonly. Segmentation of the image, creating segments, means identifying a particular thing inside the image that can be done easily with the help of k-means clustering also. Just identify if these particular points are same. Okay, so it means similar shades, similar kind of things are present over this. Okay, extract that particular object from the image. You can do that. Or gene segmentation data. So this is also one of the main technique now today to create the groups with similarity notion. So it can be done in one project I've seen. The students, not actually researchers, have created that. So blood samples are collected, and based on the similarity notion by using k-means clustering, the blood group identification was done. That's a different kind of algorithm that they have applied there. Blood group. So whether it's A, P, A plus, A minus, B plus, B minus, or A, B plus, like similarity notion that they have done. Okay. Or news article clustering. I'm having a lot many articles. So you might have seen when you're reading the newspaper online, if you're reading a particular news, okay, and if that news connected with some political ideologies or some sports, some specific kind of sports, or criminal news is there, or a general local news is there. So just like that news means connected with that, some other news are shown on your left or right hand side or the bottom of the particular page, because the clustering of that particular data is done. Means they are given with a label. Okay, it identifies what exactly kind of news is present in what particular categories. Okay, international news, political news, crime news, local news, social news, whatever, or just an informative kind of article is there. So just like that, we are seeing another kind of news which are having similar kind of genre inside. Okay, you may interested in like that. They show that people who read this, they are interested in this particular thing. How they know it? Because they have done the clustering of that news. They have given the label to it. Okay, this news belongs to this category. So what are the other news connected to same category? Here are this, so that the person will get interested more and more in that news. So he will be on your website for maximum number of times. The page ranking of your website will go up, earning will be more, like that. These are the things that we can achieve from these articles. So clustering languages, that's also very understand easy to sorry, not easy actually, clustering of languages. So whatever the word statements are given, you just separate these words or identify what kind of language is that, what kind of language is that. Okay, for example, Hindi and Marathi both use a Devanagari script, and you have written the statements, how computer will know it's Hindi or Marathi? Okay, so that's, you must be given a data first to it, find the similarities of it, create a groups, and then we'll do the predictions. If new thing is coming, new statement is coming, new language is coming, so what kind of language is that, that can identify, not without with the help of script only, but with the help of the intention, with the help of the writing style, with the help of grammar also, we can create it separately, finding the language. Okay, so clustering of the languages, we can separate it. In natural language processing algorithm devised by the Google. See, Google has done a lot many works in NLP, natural language processing. They are having many editors by which we can type in old language. They are having some voice input kind of things, which is very robust, which Google is using, which contains voices input and convert it into textual format, on textual to voice format. Like that case, this plays very important role. Okay, you just go to Google Translate, uh, and see how they have applied this clustering technique over there. Google Translate can translate language of one kind of language to another kind of language. If you put one language on right hand side, left hand side, another on right hand side, okay, so left to right kind of translation done by the Google Translate. Now, if left hand side you have mentioned one language and you enter the text in 2 or 3 languages, then also perfect translation is done onto the right hand side language by the Google Translate. How they have done that? Though you have mentioned one language and it's combination of 3 languages, then also perfect translation is done. They identifies it. Okay, this statement, whatever you written, that's in which kind of the language present there. So just consider English and Spanish. Same script is there. Script is same, but the writing style or the grammar or the word that they use inside it are different. So clustering is applied there. Based on that, you identify similarity notion, create an algorithm, and then do the predictions. Okay, now this statement is belonging to which language? Species clustering, very important application that I have seen in the species clustering. Origin of species. There is a book written by Charles Darwin. I have gone through it, and with different books connected to it. So they have given that how species are actually created and how they are connected, how many different species are present in that. So particular animal belong to which kind of species, that we can do by the dimensions of that particular animal there. Animal or birds or trees, they're also having species, groups, similarities. Okay, and then do the prediction. So and then after that, the theory of evolution can be easily proved. That's is possible there. Last is anomaly detection. As outlier detection is itself is an anomaly. Anomaly means something which is uh, like which is not within the criteria or not within the crowd. Like this algorithm can be used to identify the anomalies in many different cases. In medical imaging also this technique is used. Even in network detection also this technique is something different, something weird human body is having. So one instrument my brother is using, he's a biomedical engineer in Mumbai, one of the companies working on. So we have given that particular algorithm anomaly detection there. So that instrument scan the whole body basically and give the reports. I'm not actually aware about what report that they are giving. But what I've done, I've collected all the reports, almost hundreds of reports were there, and that reports are combined together. We identify that which bodies are having anomalies and which are not having anomalies. Basically, this is actually classification kind of things was present. But combining all together, I have identified how many groups are possible inside, and then the clusters are created. And based on that, anomalies within the body are possible. The instrument is detecting only the things as per the algorithm given there, but we have given the touch of machine learning to it. Okay, so when the touch of machine learning is given, that they are working according to machine learning. Scanning is done, we do the prediction. So there's anomalies are present or not present, or if it is present, then where the anomalies are. And like actually, many algorithm combination is that out of it, one algorithm is the k-means clustering. Okay, so that's how we can apply and make use of that k-means clustering algorithm. But the prime aim, objective behind the algorithm, then just decide how and what particular data I need to apply over there. Okay, so this is how done. From the theory point of view, I'll just show you practically how these cases are done. So we can easily get an idea. The clustering techniques is used, implementation, applications there. How to decide the value of k, which statistical methods are used and present available inside it. That will go step by step. Just a minute, I'll go ahead with some data set. I'll open the data set and I'll show you that one. Wait a minute. Uh, just a minute. Okay, so let's, yeah. Okay, so let's take this example. We'll just go ahead with using this application onward, how to find the clusters within it. Okay, so I think it is visible. Yeah, correct. It's shared. Okay. Okay. Now see, look at that. This data set. This is a simple shopping data set. Actually, bio shopping data set is present there. Inside it, some customers information is maintained. It's mentioned there. So basically, when you're shopping from a respective store, okay. So this is a data of some electronic store, I think, where we are purchasing different kind of instruments. Okay. uh, the customers, many different customers have purchased it, and they are the regular buyer from the given store. Basically, regular buyers are there. Okay, so their information is maintained here. They are given with a card. Okay, one card is given. You might be knowing in very mall, different kind of malls, the shopping cards are given to you, and based on your purchase, they are giving some points to you, and that point you can utilize further, like for that purpose, to improve their sale or increase their benefits business. So they are using these particular strategies, okay, like that. So that purchase history and many information is maintained inside the card, just like that. For example, what's the gender of the respective card holder, what's the age of it, then what's annual income that they are having. So that's mentioned over here. Annual income is mentioned. Then what's the spending score? Spending score, they are calculating based on the spending. Basically, the particular person is spending per month. Okay, and that's given from minimum 1 to maximum 100, like spending score. Okay, so these are the kind of information which is stored in the data set. Almost more than 200 different customers information maintained, and it is sorted according to the customer ID here. Okay, sorted according to the customer IDs. Remember. Okay, like this. Fine. So this kind of data is present and available in this file particularly. And now I want to create the groups within this particular data. Okay, groups within this particular data. Some n number, k number of groups you want to create. Here we are having almost 5 features as input. So you just take it out: customer ID, gender, age, annual income, and spending score. 5 different inputs are there. But in order to perform this operation with my data, okay, or my algorithm, I want to visualize it. So I take maximum 2 features which are most affecting the output. Okay, 2 features which are most affecting the output. The 2 important features only that I will decide. So I can apply either feature selection method, feature extraction methods, whatever. But without that also, I can use my own logic also, by which you can identify the 2 important feature which will affect your output. So just consider customer ID. Customer ID is just the ID, serial number, roll number. They are primarily not considered in the generation of the results. Basically, that's a customer ID, or IDs are not used to perform operations with. Remaining 4 can be considered. So gender or gender can affect the output. That will be your assumption, that can affect the output. Or age is also having the impact on the output. Means age can also having the impact in the output, affect the output. Or annual income can also have effect in the output, or spending score can also have, everyone can have effect in the output. But as per my logic, or if you apply any feature selection method, there are 2 important features which are applying the which can be useful to create the clusters which will have effect in the output, are these two: annual income and the spending score. These 2 features will primarily have the impact in the output: annual income and the spending score. Based on that, means they are the most important criteria by which the clusters can be created. And why to create these clusters? See, to have a groups of your customers, okay, those who are purchasing the instruments from you. So you have to create a group of the customers. And once the group of customers are created, you can identify the mindset of a group of customers will be same. First group, second group, third group will be same. And in future, if you want to sell some kind of product, so you don't have to sell to whole different kind of customer. Just consider 100 customers I'm having. and I want to sell a product to the particular customer. So we actually sending the product to all of the customers, all 100 customers. In prior to that, if I'm knowing these group of customers may be interested in my product, okay, this group of customers may be interested in my product, so I'll focus on them only. This 20, this 30. So my money will be saved in marketing, as well as my efforts will also be saved. That is my prime aim is there, to create the group or to create the clusters within the respective data for this data set basically. Okay, so maybe I'm creating 10 clusters, and out of 200 entries, 10 means 20 to 8, 15 to 20 or 25 people will be there that will be created. So I'll be focusing on that particular people only. Remaining people will not be considered because they may not be interested, because their mindset is something different. So that thing I'm going to achieve from that. So I'll create n k number of clusters here. It once the group is formed, once the group is separated, then after, with the help of that, I just can use this data for my marketing. When new product is coming, then I'll be providing them the particular thing. Okay, and then based on that, will increase or improve our sale. That is my primary task is present over here. So let's see how to do these operations. I'll just show you. I have opened my editor here. Okay, and wait a minute, not shared again. So let's go for that. Let us see. Yeah. So see how this clustering is possible, and technically how it is done. Even we can see how what is the criteria to select the value of k. Okay, what's the criteria to select the value of k? That also I'll show you. Okay, so first of all, I need to import that particular file in the code. Okay, so just a minute, I'll just show you how can I import this particular file in the code. I'll go to my data set. It's there in the k means. Huh. Now see, let's open that, let's separate it, and then let's see how k-means clustering can be actually applied to perform the operations with. Okay, so just check it out. Here is your data. So say this. So, see, so this is the data set that we are using here. This one. Okay, customer ID, gender, age, annual income, spending score. Directly using the respective methods. Okay, using the respective methods, I have imported this file in the code. CSV file. It's a comma separated values file. So most of the time, when you use a data set, the data set maximum number of time comes with the CSV. So I've read that, and then I've saved that in variable df. Okay, df stands for data frame basically. Okay, can just check it out. The data which I've imported is containing the similar kind of things. Even you can see the different properties of it, like shape. Shape means 200 rows and 5 columns are there inside it. Okay, and out of all of the 5 columns, which particular columns I want to take as input, that I require, like annual income and the spending score. These two columns are there, 0, 1, 2, 3. Column number 3 and 4. Okay, column number 3 and 4, I just want to take as input to me. Okay, to create the cluster, to form the group. So I know that these features are having highest impact in the output. So I'll take that two respective features here, and with the help of these two features, will form a clustering model, a machine learning model of unsupervised learning, and then we'll see whether these groups are perfectly done or not. Okay, just like on presentation I was shown, before and after. Before means the unclustered data, and after the clustered data. Then you can identify similarities are present inside it, are perfectly created or not. Okay, so this is done. I just imported the file, And now I want to extract two important features which are required for my operations. Let's say X is the uh, column, or X is the data that I'm using as input, a variable name. Okay. Okay. So let's take this. X is equal to, so what I've done here, basically I'm using all the columns from 3 onwards also. So column number 3 is this, and onwards all means only one column is present there, that is mentioned over here. Okay, or I'll mention like that also. So, okay, so those who want to work with that, I'll share this code with you. So if you want to go ahead with that, it's not that much difficult to understand if you're writing a Python programming language. Very easy and simple kind of plain structures are present in Python. So you want to work on data analytics or in any kind of area, not in a specific area. So any kind of area, this is very useful to work with. So check it out. The third and fourth column are taken, annual income and the spending score. It's a table extraction, slicing I have applied, and then X is taken as input. Okay, X is the data set which I extracted from, and now I'll be creating the groups of clusters within on that particular data over here. Okay, so X is taken. Now, after that, I first thing is that I want to identify how many number of clusters are possible inside that. 200 rows are there. Okay, so wait a minute. I'll go to presentation again and we'll continue with this. Okay, how many clusters? There are two commonly used methods to determine the ideal number of clusters possible in k-means. Okay, I have taken the data. Now I need to specify what is the value of k. So two methods are used to create the groups within the data. The first method is called as the elbow method. Elbow, literally what elbow is, just like that, it's formed over here. And second is called as the seal out method. Seal out method. Seal out is the pure statistical method actually, which is used to find the number of clusters here. Okay, so let's go with this. The first is elbow method. Elbow method is finding the sum squared error. Let's talk in detail what exactly sum squared error is, and then how we can find how many ideal groups are possible there. First of all, complete is sum squared error, SSE, for some values of key. Example like 2, 4, 6, 8, 10, like that. SSE is defined as the sum of the square distance between each member of the cluster and its centroid. Okay, so say that. I'll explain the formula again. SSE is equal to distance of a particular point X and its centroid. Okay, X and its centroid. Centroid is fixed. At the end, we are getting centroid. Centroid is fixed for all the element of the cluster. Okay, their distance. Fine. All of their sums. Fine. Whatever number of values are there, their sums. And for every value of k, their sum. For every value of k, every point of it and its distance square is identified, and we got the sum squared error, SSE. Now consider logically, just think about it. K, if I am using some specific value of k, okay, like value of k is equal to 1, or like k equal to 2, k equal to 3, k equal to 4. What do you think? As you increase the value of k, SSE will decrease or increase? Obviously, SSE will decrease, because obviously number of clusters will grow, number of elements inside the clusters will also grow. As it started growing, remember, as it started growing, your error will uh, drop down. Remember, it will decrease when value of k is equal to total number of elements. For example, 200 elements are there and 200 clusters are created. So obviously SSE will be 0 because every point itself will be a centroid. Adenine itself will be a centroid. So no error, 0 error will be there. One point in one cluster is possible in that case. Okay. So no error is present in that case. Remember it. Fine. Okay. No error is present. So obviously, when value of k equal to 1, highest amount of error will be present because in single cluster, every point will be present. As you started to 2, 3, 4, 5, 6, 7 till k value there, SSE will start decreasing. Okay. And if we plot k against the SSE, you will see that the error decreases as k gets larger. This is because when the number of cluster increases, they should be smaller. So distortion is also smaller. Okay. First time I'm having 10, 100 elements in the cluster. If you change the value, 80 elements, 70, 50, 20, so as number of elements are decreasing, SSE will also decrease along with them. So the idea of elbow method is that to choose the k at which SSE decreases abruptly, it produces an elbow effect. Elbow point is chosen on the graph, basically. From that particular point, the decreasing rate of the error is slowed down. That is called as the elbow point. And that is the ideal value of k. From that particular point, if error rate is decreased so much smaller, so that's called as the elbow point, and that is what the ideal value of k is. Like practically, this elbow point is identified, and exactly this is the ideal value of k or not. So just I'm going to show my program again. I got clusters over here, and now let's apply. So from there's a package called sklearn. So I create one package there, which is containing the sub packages. Okay, to perform the operations with. Okay. So just like cluster, and I'm having a k-means inside. With the help of that k-means class, I can create the object of it, and then I can directly apply it. I show you how exactly SSC is calculated here. Okay, so let's check it. So I create object k-means, and it contains one parameter given to it. That's called as n clusters, which is equal to 1, for example. So what I done, I created the object of the k-means algorithm here. Contain the number of clusters equal to 1, and I got that km presented over here. Okay, so object is created. Now km equal to km dot. Okay, so fit predict is the method by which you apply your data set algorithm object. I want to take one number of clusters in it, and then the input I have provided. Input is x, which is shown over here. See this. Input is x. X is given. I applied. I want to get one cluster out of it. Okay, it's created, and now I'll just show uh, the value of the see some error. Just a minute. We got this k object created here. All the elements which are present inside it are containing the zero value, the zero number of clusters assigned to it. Let's change it to, and now you can see it. These are numbers. I create two clusters in this project. Means I apply this k algorithm on the value x. Okay, which Sorry for this. It was muted, disconnected automatically. I don't know why. Okay. So just check it. So yeah, I apply the fit predict function here, and x value is given as input, your data set, which contains two elements present inside it. And I want two clusters for that. So it's given 0 and 1. Only numbers are assigned. I'll show the graphical presentation also. For all the points are in 0 and remaining all points are in cluster number 1. Predicted. But I don't know whether the value of n clusters I have put is correct or not. Okay. The value which I have put over here is correct or not. Okay. So what I'll do in this, I just have to identify how much error I am having inside this particular thing, this particular object, that also we can make use of. Okay, so let's check it how to do this. So check this. See, if I plot the error for the number of clusters, so in this case means the example I mentioned over here, this is just an example. You can have a plot. Here the number of clusters are given on x side, 2, 4, 6, 8, 12, 14, something. Number of clusters are there. Actually, 2, 3, 4, 5, 6, 7 are there here, clusters. And on the y-axis is some squared error. Okay, for example, in cluster number 1, I'm having some squared error greater than 4,000 for this case. This case means this is just an example. It's not related with our example which I'm showing over here. For 2, it is 2,800 almost. For 3, it is almost 1,900. For 4, it is almost 1,500, decreasing. And if you see this effect here on the graph from point number 6 onwards, okay, the rate of decreasing the error change is almost flattened, almost, not exactly, but it is decreased. So 6 is creating an elbow effect on that particular graph. Okay, it's creating an elbow effect. So ideal value of k is equal to 6 for this particular case. Ideal value of k is 6. So I'll create 6 cluster for this case. Means not our case. This is just an example. Remember that. So in our case, I'll show you how these operations are actually performed. Okay. So let's say this. This is how prediction is done, and now I'll show the value of it. So let's see. Okay. So it's fitted. Sorry, something is missing. What's missing? X number of clusters I given I, and just a minute. Yeah. So number of clusters I have given 2. I have applied the data to particular object there. You can see number of clusters are given 2, and now km dot inertia. It's a special variable present inside this particular class. Special variable inertia, we store the sum squared error for respective value of k. Okay, we store the sum squared error for the respective value of k, which is mentioned. The respective value of k which you have mentioned here is the 2. For value 2 is 1,81,000. Inertia means SSE, sum squared error. His name is different here, so don't confuse. Inertia itself is a SSE, sum squared error for value of k equal to 2. 1,81,363. Okay, now if you change the value of clusters to 5, so let's go to 3. 1,81,000 is there. If I make it 3, it is 1,06,000. Fine. It is 4, 73,000. See that how it changes. 5, 44,000, and last I'll show 6, 37,000. Okay, so the thing is that as you increase the number of clusters, your sum squared error decreases. Okay, if you increase the number of clusters, your sum squared error decreases. But I want a plot of these values. I have applied it, but directly it's possible to have that. But I want a plot by which you can see the elbow effect and identify the ideal value of k in that case. So perfect groups are possible. So let's see how to do this one. What I'll do, let's make a trial error method. Like I'll create an array, like SSE is array, okay, which is list, actually empty list I'm creating. And after that, whatever values are there, I'll start from 1 to, for example, 15. 1 to 15. Okay, value of k, and then I'll plot the SSE over there. So let's see. So I'm using a for loop. So let's use for k in range which will start from 1 till 16 means actually it is 15. Okay, then create the object of k means, and every time I am changing the value of clusters equal to k. Okay, k means the this particular value which is I'm taking from the range of elements. First of all, the value of k will be 1, then next time 2, 3, 4, 5, 6, 7, 8, like till 15 it will go. Okay, so in this way the values will be created, correct? Okay, and then let's fit it. Fit means apply. Okay, apply the algorithm to given data, and once it is fitted, whatever the inertia is present, that inertia I will store into the sse list. Okay, so sse dot append. Append means to attach. Okay, append the value. Which value? Km dot inertia. This value inertia underscore means underscore are the special variables or the attributes of the object. They are ended with the underscore. This is the general terminology used in Python. That's why it's like that. So I'll execute this. You can see this. So I started from 1 to every time the k-means algorithm is applied here and identified the SSE appended into the particular list. So if I print this list, see inertia generated here. This is inertia for cluster number 1, that is 2,69,000, then 181, then 16, then 73, 44, 37, 30, 25, 21, 20, 17, 15, 14, 13, 11. Okay, like we go till 200, so it will go to 0. The 200 elements are present inside it, like that. Okay, so 1 to 16, I just 1 to 16 is 15 actually. It's a problem of it's a property of this algorithm, this function actually, the range function, which will start from lower bound to higher bound minus 1. Okay, just like index, we start from 0 and end with n minus 1. So here also it's minus 1 is there. Till 15 only, 15 elements are presented here. Now I want to plot it. Let's plot that, and then we'll see the elbow effect in the output, whether elbow effect is created, and if it is created, then where the elbow is, what's the ideal value of elbow. Okay, so let's go for that. So I just want to import the plotting package. Okay, uh, just a minute, import as plt, and let's see, plot plt dot plot. So on x side I'm having the value of k, correct? So value of k is starting from 1 to 16, and on y side I'm having sse, correct? Y side I'm having sse, and I'll have that names also to the x and y. On x side we have the number of clusters, and on y side we'll be having the sse. See this, see, you can observe this. I'll make it more clear by adding some more properties to it. So let's have the grid also, and let's have plt dot x sticks, which will start from 0 to 120. Sorry, not 120. Let's have x sticks. One by one, we'll go for that. Range 0 to 16. Okay. Now see this. So you can observe the elbow point. Elbow point is, what do you think? 5. This one. This is the elbow point, from where the rate of decrease in of the SSE is slowed down from here onwards. Okay, so you can just check it out what I've done. Here all the SSEs are calculated, some squared error are calculated by appending everyone's SSE to the SSE list. Okay, and then I have plotted it, okay, in this way. So on X side I'm having the number of clusters, 1 to 15. Okay, correct. And on y side I am plotting the respective SSC which I have taken in the for loop from the k-means algorithm. Okay, so it's plotted here like that. So you can observe that here from 5 onwards, here 5 is the elbow point that you can consider here. So just check light. This is the marker. So marker will clearly visualize it. Now see. Yeah. So 5 is the elbow point, which is shown. Now, for my case, which I am shown, the customer's data which are collected for the respective store is having 5 ideal value of the key. And when you 5 ideal value of the key, the clustering can be easily seen there. This is the first method which we can use to check the number of clusters or identify the number of clusters there. Apart from that, I'm having one more method. Okay, just see this one. We go to presentation. Yeah. So this is we can apply it inside this particular object. We'll come back to this particular point also. How cluster centers are found, how labels are found, how inertia is found. Inertia already we have seen. This is the output of the same program which I've shown over here. Now the second method, which is used to find the ideal value of k, is the Silhout method. Silhout analysis. This is what we call Silhout analysis. So Silhout analysis is the way to measure how close each point in a cluster is to the points in its neighboring cluster. Okay, how close is that? Means inter-cluster similarity and intra-cluster similarity. This concept is used in the Silhout analysis. Okay, so this is the way to find out the optimum value of k using k-means clustering that we are using. So basically, Silhout values are taken, and that lies within a range -1 to 1, -1 to +1. Okay, value of +1 means the sample is far away from its neighboring cluster and close to the centroid. Okay, far away from the neighboring cluster and close to the centroid. That's what positive, more and more positive value of k is present, maybe equal to +1. And similarly, -1 value, Silhout score we call it as -1, indicates the point is very close to its neighboring cluster. Okay, very close to neighboring cluster. And so it is not close to its centroid. It is far away from the centroid of its own, but it is close to the neighboring cluster. That is value of negative will show us. Value of 0 means it is boundary of the distance between the two clusters. The value of +1 is the ideal, and -1 is least preferred. Hence, higher value is better than the cluster configuration. Remember, it should have highest Silhout scores. Now I'll show you what formula is used there and how exactly they are connected. See this one. In the data, let's define A of I. Okay, just an example. Let's define a formula there. A of I is the to be the mean distance of point with respect to I with respect to all other point in the cluster assigned in A. Okay. In cluster A, I'm having a distance of point I. A of I is calculated. We can interpret A of I as how well the point is assigned to the cluster. Smaller the value, better the assignment. Okay. And let's define B of I. Another point is present, which is to be the mean distance of point I with respect to other point to the neighboring cluster called as B. A of I is a point in A cluster. B of I is a point in the B cluster, which is a neighbor. So they are neighbor of each other. Okay. The cluster B is the cluster to which point I is not assigned, but its distance is closest among all of the clusters. And now Silhout score S of I is calculated as, see the formula I just mentioned over here, B of I minus A of I, B of I minus A of I divided by max of B of I and A of I. That is what will give the Silhout score. Silhout score will be given by this particular formula S of I. So B of I is a point in cluster B, A of I is a point in the cluster A, and what's the max of it? It's divided, okay, with the difference between B of I and A of I. The value can become positive or negative. If it is becoming positive, it means that the cluster is very close to its own centroid. If it's negative, it is almost somewhere away from this centroid. Remember, so what value we require to have ideal value of seal out? Positive value. So most positive, most highest value should be present for the respective value of k, which give the ideal value of k. That's how seal out method is done. So as I mentioned in this slide also, this value lies within -1 to 1. +1 indicate the sample is far away from its neighboring cluster and very close to its own cluster it's assigned. Similarly, -1 indicates the point is close to its neighboring cluster than the cluster is assigned, called as the seal out method to do. So our task is to maximize, to have the maximum value of seal out score for a respective value of k, for the respective value of k. Remember, and let's see this one. We'll see this practically, and then we'll compare elbow method and the seal out method. What's the relationship that they are having? Whether they are giving same result or not. That is very important. If they are giving same result, then it is proved that value of ideal value of k is that. So in our case, in elbow method, we have seen the ideal value 5, and now let's see for seal out method what will happen. Okay, so there is a function called as seal out score, which is used to find the seal out score of it. So I'll just do an operation here. Check this. So same task which is shown over here. Let's see the seal out score. So from sklearn dot metrics, I can import the seal out score function. Okay, sorry, seal out score. Okay, and let's create a list here whose name is SILS seal out. Okay, we'll start from this. So LF cluster is equal to k fitted. Okay, sorry, it's prediction is also required. We require labels over there. Labels equal to fit predict. Okay, and yeah, seal out score also I require. S is equal to, its function will identify the seal out score. Labels correct, and to the list after seal out score every value. That's why I just mentioned there S here, and yeah, it's done. Some error is there. I need to rectify that error. See what I've done here. An empty list is formed, that is SILH seal out scores, and then I started from k equal to 1 till 15. Okay, then object of k means is created with value of k every time 1 to 15. Different clusters are created every time one cluster, applied it, and their labels are identified. Labels the cluster numbers actually, which I shown previously. It will start 0, 0, 1, 0, 1, 2. As per the number of k given, the labels are given to the particular cluster are called as labels, that is identified by fit predict. These labels I have assigned to the seal out score here. So X and its labels, they are given as input to seal out score. We'll identify the score of it, and then I'll appending it. One problem is there. It is not able to have a seal out score for value of k equal to 1 because neighboring cluster is not there. Neighboring cluster is not present. That's why that's a shown over here actually. Top label is 1. Invalid values are valid values are 2 2 number of samples minus 1. Remember, because neighboring cluster is not present for value 1. That's why it should start with 2. Yeah. Done. Seal out score X comma labels are given, and all of the values of the seal out score are calculated for every value k. If I print it, you can check the seal out scores as the seal was created. Okay, and almost all are positive. So ideally, value of k are good. Negative values are algorithm has worked perfectly. That you can find from that. Values are taken, but I want to identify what is the ideal value of the k. That's very important to know over here. What is the ideal value of k? So for this purpose, again I can plot it, but without plotting also we can do the similar operation. But let's have a plot. So plt dot bar. Let's use the bar plot, plotting this particular value on x side. I'll make use of the range function, which will have 0 to 16, and on y side I'll plot the SILH. Check this. and see where the highest bar is present. Where the highest bar is present. So I'll take this ticks also. So ticks exactly gives the values. Yeah, see this. Where the highest bar is present. 5. Again, seal out scores. Again, started from 2, 3, 4, 5. So on 5 here, I am not taking the one value because I know neighbor cluster is not present over there. Okay, 5. Here the highest bar is present. It means that for 5, highest seal out score is present. Highest positive seal out score is present. So, so that ideal value of k for this case also 5. So it is confirmed now that elbow is also saying value equal to 5. Secret is also telling value equal to 5. So by using value 5 in my algorithm, I'll carry forward it, and then I'll create the clusters. Then I will form three perfect groups possible. Yeah, I can ensure that. And then based on that, the groups can be separated. We can make use of this particular data afterwards with the help of this. So this is how the seal out score is delivered. It's shown over here also. Sorry, the presentation. Just a minute. Yeah, see, showing this one. So exactly what I have done, and I just have shown this one also in seal out method, and even one more. If I want to wait a minute, if I want to print it, because it's not a graphical method actually, statistical method. I just want to make use of this formula also. So see, max of SILH. So I know that this is a max of SILH, but whose max is that? That is not known. So let's use max of SILH of index of this value plus 2. Something is missing. Index of this one. This should not be done there. Plus 2. Yeah. Oh, still that's a problem. I have taken this directly. So this max, right? Whose value is present there? Yeah, correct. Now 5. See it. SIL dot index of max means where the max is present, its index I want. So basically I given plus 2. Why? Because we have started from 2 onwards. So 0 and 1 are not considered. In array, in list, we have 0th value, 1 value also, which is not considered here. That's why this 2 is added. We have started from 1, sorry, 2, 3, 4, 5 onwards. So ideal value of k for this case also a 5. Okay. Uh, so this is how we can identify the ideal value of k, and based on that, the clustering operations are possible. Okay. Uh, just a minute. Okay, so this is done. We are okay. Almost time is over. Remaining part we'll see after the break. Means one more session is there, because this part will not be covered. It will take almost 15 to 20 minutes to cover it. And in the second part also, I'll show one more clustering method, which is easy actually, connected to the same, because many things theoretically we already covered. The thing which we are required from technical point of view, that also I'll show. Okay, ma'am.
Yes, sir.
So we'll take a break, and remaining part we'll see after the break.
Yes, sir.
No
We'll
problem.
take a 10-minute break. Is it fine, sir?
Yeah, no problem. Thank
Yeah.
you.
Participants are requested to remain in the same meeting. We'll take a 10 minutes break and meet back. Thank you all. Hello, sir.
Hello, ma'am. Can you start?
Yes, sir, please.
Thank you. So, welcome back. Let's continue with the topic we have remained with. We are not see the visualization yet. So, these are the methods that by which we can see how many clusters, how many groups you can create within the respective data. I just choose any data which is feasible to have the clusters creation over here. Okay. So, select method also telling 5, and elbow method is also telling the value of k is 5. Now let's apply and let's see how this clustering is actually possible. Okay, before that, I'll show you one thing. I'll plot this data and then I'll show you how this clustering is possible actually. Okay, so let's see. I'll plot it. This particular data. X side, I'll have the annual income, and Y side, I'll plot the spending score, and based on that, we'll see it. So let's see. PLT dot plot. So in X, we are having these two values. So column number 0 on X side and the column number 1 on Y side. Just a minute, what's the problem? Sorry, it's not trying to have that values here. It's there in data frame format. Sorry for this. See this. See this. So this is unclustered data actually. I'll just show you where how exactly it is plotted. On the X side, so as per the data set as mentioned there, the annual income is present on the X side, and on the Y side, I'm having the spending score. Okay, both of these values are ranging from 0 to 100. Okay, see this one. So this is unclustered data, which is before. Okay, so before clustering, how the data is looking like. Okay, so that's shown over here. And in this data, as we have seen, we require 5 groups, 5 distinct groups to be created. And the rising k means how they are formed, how they are seen, that we will see. So this is the unclustered data. I'll just make it more clear. Let's make dot marker. Okay, see this. This is the unclustered data. And now let's apply the cluster. So what exactly the algorithm does? So as we have seen that based on the similarity notion, the values are assigned, the clusters are assigned with the respective centroids, and everyone is given a number. Means if 5 values are mentioned, so it will start from 0, 1, 2, 3, 4 onwards. So 0, 1, 2, 3, 4. These 5 values will be given to the label that we call, and based on that labels, we can separate the data in different kind of files, or even visualization can also be done easily there. So let's see how to do this one. So let's create the object of k means. Km is equal to k means, and parameter should be given is number of clusters that you want. So I given 5 clusters here. Update is created, and now labels is equal to km dot fit predict. Okay, so fit predict is the method which we are applying on the data set. How many clusters you want? That's assigned 5 over there, and the respective labels are generated. Label will start from 0 till 4, and whatever number of element that X is having internally inside. So X is having total number of element 200 inside it, and for every element, based on the closest cluster, based on the closest centroid, the number is assigned to it from 0 to 4, and that I have stored into the variable label. So let's see this labels. So 3, 4, 1, 2, 0, all 200 are assigned with these values. So point number 1 is in third cluster, number 2 fourth, or this is in cluster number 1, this is in cluster number 0, this is cluster number 2. Okay, like this. In this way, these labels are extracted and they have saved into the variable labels. These values are again stored into one more variable here called as labels. In this variable also it is stored km dot labels also. And even if you want to see the inertia, means how much The SSC that this carries for value of k equal to 5 is 44,448, like that. And what are the 5 centroids present? After maximization, when you, okay, we have seen the concept of expectation and maximization. So maximization is done. We are having recalculated centroids there. So recalculated centroids can also be uh, saved. That can be seen with the help of one more variable. I'll just show you. See, this is how you can see. These are the recalculated centroids. 5 centroids are there, and that 5 centroids are seen over here. You can just check it out. Okay, just see this. This is the annual income and this is the spending score. So based on that, this is the first centroid, second centroid, third, fourth, five. 5 centroids are generated because value of k is equal to 5 given over here. Okay, fine. So this is how the numbers are assigned, which I just given the numbers now, but clustered data and unclustered data. So how to identify and how to use that clustered and unclustered data, that we need to check it here. So I'll show you the clustered data now, how exactly the clustered data will be present. Okay, so let's see this. So non-cluster data we have seen, and now after applying the clusters, how the data will look like. So what I'll do, the cluster numbers I'll assign to the colors. So wherever the cluster number is 0, they will have this common color. Okay, which point is having cluster number 0 will have common color. Cluster number 1 common color, 2, 3, 4, everyone will be given a common color number to it. So when you plot that data, so you'll have different colors for different kind of the colors there. So to do this one, I'm assigning these labels to the color, and you can see this one now. Whatever labels I got, these labels I assigned to the color, this one. And now we can just observe this. See, the group which I have formed here, it's like that. Okay, clusters. This is cluster for one cluster. This is another cluster. This is one more, and these are one more clusters. Like, and you can observe that this is perfect. Perfectly 5 are possible. Exactly 5. Perfectly 5. How in this particular unclustered data, how perfect 5 clusters are possible, that we can identify from here. Check this. Now, what my interpretations are, as we can see, the data set is the customers who are purchasing the items from the respective store. That's mentioned there. Spending score according to the annual income and spending score. 5 groups I identified. Now you can observe that these people, which are okay shown in the light green color, almost a pista color we call it as. So this is shown over here. Okay, so in this color, the people who are coming under this group are the having lower income and low spending score. These people. Okay, so they are of same mindset. Almost they are having 40-40, means 0 to 40 spending score, 0 to 40 annual income is present to them. Okay, that is here lower. If you go for this one violet color, okay, so they are having high annual income and the low spending score. Okay, high annual income and the low spending score is there for these particular people. So their mindset is different. For these people, both are high. Okay, spending score is also high, and the annual income is also high for these particular people. For the yellow one, this one, so they are having high spending score but low income is present. High spending score and low income, which are in this particular group. And the fifth one, they are very important. They are present over there at the center of it, at the middle of the graph. It's called middle class. They are average. Everything is average. Annual income is also average, and spending score is also average. This one, actually, if you see that highest number of people are present in this particular group, you can count also by the concept of Boolean filtering. With the help of Boolean filtering concept, we can identify how many number of elements are there, and we can extract name also from the given data. That is also possible. I'll show that one also, how to do these operations specifically. So 5 groups can check it, and then perform the operations of separating and creating. If I want to keep them just side of each other. So let's see how to do this one. So I'll create a sub graph, actually sub plot here. So one subplot, okay, plot of I require uh, two columns and one row. Okay, two columns and one row. Plot number one. If you're knowing MATLAB, so same kind of things are present there. Plot number two. See this before and after. So and see this. Okay, so before and after is just shown here. I used a default marker so it will be easy for me to understand. Yeah, see this. One cluster data is here, and this is the cluster data. After applying it, after applying, I just have mentioned that. So like that, how perfectly five groups are present and possible just by keeping them side by side of each other. Okay. And one more thing, if a new element is coming, new uh, people or new kind of person is coming, so I just can identify that this particular person is in which category, whether it is in cluster number 0, cluster number 1, cluster number 2, or cluster number 3, like that. Okay, even on this plane I can draw the centroids also. So I just want to have a centroids. So let's see this. I'll just show you how to draw these centroids. So here itself the centroids are possible. Okay, so centroids are saved in the variable cluster centers. Okay, yeah, correct. And here also km dot cluster centers. Okay, so the cluster centers, let's make it size 300. Now you can check it. The cluster centroids I have plotted there. Let's use color is black. See, the cluster centers are also shown there. So as I shown, it's possible to have this cluster center into the object already. They are shown here. And with the help of S300, they are made bold. Okay, 300 is the size of it. Color I put black. And check centroids are exactly at the center. Means average of all the respective elements are present there. They are the cluster centroids, which are shown on this particular plot. Okay, and they are at equidistance. You can observe that they are perfectly, almost not exactly, but at equidistance they are present. They are taking one by one element, and the point which is nearest to the respective element, you can observe. So we take any point, that point's nearest clusteroid centroid cluster centroid is own centroid maximum. So that's what show the accuracy of the respective algorithm over here. Okay, fine. One important task is remaining here, and that task is to separate the clusters. One more, to predict the cluster also, that is also possible, or to separate the cluster is also possible. Separate the cluster means, just take an example that a new customer is coming and you have to identify in which particular group it should go. So let's have a new, and that is having 34 is the annual income, and spending score is 59, something like that. Okay, and if I do, so let's use km dot predict. Okay, new number 4. So this is number 4. Here 34 and 59, and then by using the predict function. So predict is a common function which is used for supervised, unsupervised also. Unsupervised also I am having that. When the clustering is done, then 34, 59. So it's in array format. So let's make it 0. So fourth number of cluster, it will go. If I make it to 19, now see it's cluster number 3 in, it will go. Perfect. Then if you go to this one as 94 and 19, cluster number 0 is present over there. And if you go for 94 and 88, cluster number 2 is present over there, like that, in this way. So in this way, the predictions are also possible. We got that once again. Algorithm is built, algorithm is trained, algorithm has learned the features, created the model, and now when new customer is coming, we just apply the predict function and get that particular customer in your group. Okay, your group means whatever 0, 1, 2, 3, 4, and separate it. And the most important part, what I have done, I have created the numbers, I have given the label numbers, and now based on that, I need to separate them also. How to separate? So to separate, I'll be having one concept in Python I've used called as Boolean filtering. With the help of Boolean filtering, this data can be separated. Now, how to? So let's say I'm having my data X, or I'm having my data DF, I think, which I used at the start of it. Yeah, DF. From this DF, I need to set the data. Labels is equal to 0. So wherever the labels are 0, that data I'm extracting. Check it out. Where the labels is equal to 0, I'm extracting that data 124, 128, 130, 134, like. Okay, labels equal to 0. And if you want to identify total length, so check 35 elements are there in cluster number 0 present, and cluster number 1, 81 element, this is middle class, I think, the center element. 39 are number 2, then 23 are number 3, and 22 are in number 4. See, total count, question number 0, 1, 2, 3, and 4. Different are there, because it's taking that concept one by one. It's not compulsory that every element should be present. Like if you have 200 are there, so it's not compulsory that everyone should have 400, 40, 40, 40 elements. Randomized data is there. Okay, will go randomly in different kind of the clusters. Okay, so this is how count we can see. And if I want to save this data into a variable or into a file actually, so let's say for example, I want to save this cluster number 1, people in 81 people, or let's see cluster number 2, 39, the 39 people in a file. So let's make it new df, any variable name can be assigned. Okay, and where the labels are 2. Okay, only that data I've extracted and I've saved that into the new data frame, new df. Okay, once it is saved into the new df, then I can make save into to csv. Okay, let's convert it to csv and give a name as 2.csv. Okay, index, sorry, and check it out. Okay, so the people who belongs to cluster number 2, I have saved in a variable 2.csv, in a file, sorry, not variable, file 2.csv, which I can open, and then I'll show you this particular file. So it is saved in my current working directory. I'll just open that and show you which particular customers are in cluster number 2 present. Yeah, see this one. Okay, see this. These are the customer IDs and the people. So 39 are present. 39 people are present who are in number 2. Their data I extracted and I have separated in a separate file, like 0, 1, 2, 3, 4. All of their data can be saved in different kind of the files, and then I can redistribute it. I can use that data for product operation processing, which I require to do with. For this particular example, I'll be using this data for the marketing purpose, or for sending something to this group of people separately. Okay, remember they are not sequential, they are randomly taken. 124, 126, 128, and 30. In this way, the data can be separated and we can use this particular data. So this is what we call as the k-means clustering technique. K-means clustering, where value of k should be given in advance. We'll be using that. We are devising a model, we are creating a model, we are doing the predictions, we are saving it, And what we have seen, the most important is the ideal value of k. How to check the ideal value of k by using elbow method, by using syllabus method, can use of it, and based on that k can be identified. It's not required to use this method. If you want, I want 10 clusters, so you can assign the 10 also. Okay, you want 6 clusters, you can assign the 6 also. 5 clusters and assign 5, like in this way. Okay, so let's come with the second part of the clustering technique, that's agglomerative kind of clustering, which is non-divisive clustering. Is using some different mechanism, different way of using the algorithm. This is called a hierarchical clustering, basically agglomerative or hierarchical clustering. With the help of that, clustering is done. Methodology is different. Maybe the clusters created by that clustering methods are different. Maybe I'll show you where the difference lies actually when we apply this kind of clustering technique and check the output. So let's see the second part of the clustering here. Okay, let me start this. Wait a minute. Just a minute. I'll start the second part of the clustering techniques. It's called as hierarchical clustering. Yeah. Yeah. So hierarchical clustering, the another method also popular as like means clustering, where see how apply the hierarchical clustering technique is as well as first thing is that we need to understand how exactly the concept, what is the idea behind it, whether this idea is useful, can be, it can be more fun, or can be useful for your point of view, your application point of view. This you can find. And the methods, again, statistical methods are present to work with the hierarchical clustering technique. Okay. Hierarchical clustering is also known as the hierarchical cluster analysis, which is used to perform the same operation that we do with the k-means clustering here. To create a group of people or create the group of data which we expect the respective data set, hierarchical clustering. Okay. Called as, so the point of clusters where each cluster is distinct from each other, and the object each cluster
Hello,
always should
sir.
be
Sorry
to
to disturb you.
each other. I told.
Sir, your PPT
Yeah.
is not visible. Slides are not visible. Sir,
Okay.
the
Is it
slides.
visible?
No, sir, not yet. And your voice is a bit low, so please can you adjust mic?
Yes. Voice is okay now?
Voice is okay. The
Yes.
slides are not visible yet. Voice is okay. The slides are.
Just a minute. Okay. Is it visible now? Yeah. Is it seen?
Uh, yes, sir. Yes, they are visible now.
Okay. Fine. Thank you. Yeah. Okay. So, what exactly the hierarchical clustering does? We'll see. The main part, as we know from the name hierarchy, so tree wise grouping, tree operational looking are done with the help of the hierarchical clustering over here. So in k-means also we have seen the property that the clustering should be like that. There should be high intra-cluster similarity and low intra-cluster similarities are there. So keeping this thing in mind, hierarchical clustering also create the groups within the data. Okay, so some steps are there, two steps which I shown over here. Clustering start by treating each observation as a separate cluster, just inverse of it, agglomerative. Each observation is the separate cluster. Then repeatedly execute the two steps. Identify the cluster which are closest together. So for example, 10 points are there. 10 clusters are taken first. Then out of 10 from the first, which is the nearest element for the second, for that first, for second, third, fourth, nearest. Again by using the formulas, which is the closest element to that, which is the closest will be taken in that particular group. Another group is found, and then we'll go for taking another element in the group, then next element, then next element. This technique form a hierarchy. Okay, a tree is formed, and they merge the two most similar clusters, which are performing the operations until all the clusters are not merged together. So it forms a tree, it forms a hierarchy over there. It's called as hierarchy clustering. Let's see, let's go step by step. Let's go by visualization also. Then we get an idea how exactly hierarchy clustering works here. At the start, treat each data point as one cluster. Therefore, the number of clusters at the start will be k. So number of k. So whatever number of values are there, that will be the number of clusters initially. So k is an integer representing the number of data points. Now after that, form the cluster by joining the two closest data point, resulting into k minus 1 cluster. Just like 10 elements are present, 10 cluster initially will be present. After that, two closest element we are going to join. So 9 cluster will be formed. One cluster will have 2 points inside it, correct? And 9 clusters will be formed. Then again join two closest element. 8 will be there. Then 7, then 6, 4. So as soon as you start joining, it creates a tree-wise structure, and that is given a name there. I'll show you what name it carries. So repeat these steps until one big cluster is formed. Initially, at the root node is formed, we are going to join them one by one, and hierarchy is generated. Once a single cluster is formed, a dendrogram, okay, as I told, it's a graph is formed, a tree is formed basically, and that tree is called as a dendrogram. They are used to divide into multiple clusters depending upon the problem. Divide on the multiple cluster depending upon the problem. Okay, so let's see that how it perform the operation. So check this. So graphically, we'll get a clear idea how these values are actually taken. Okay, so let's see. I'm having 6 points in my cluster here. Identify the two closest point, like 6 points are there. Out of all, the two closest point are this. These two are the closest point present over here. First, second, these two, for example. So what we'll do, we'll create a group of them. We'll create a cluster of these 2 points together. So by converting it just like that, here a common cluster is formed over here. So from 6 it will come to 5. 5 clusters are generated. Okay, then the next closest point is this one. Okay, this or this is also possible. So if I consider this, so like the group of all these three is formed, and now 4 clusters are remaining. They are connected. Or one more possibility is there, that we can connect these two. These two and these two, or parallelly also possible, parallel also possible. So when it's parallelly done, so they will come at the same level in form of the graphs. Let's see. Okay, that's done. Now the next element will be taking this. For example, this also done and this is also done. Both are done, and this point is now closest to this particular element here. So now take this point also into it. It's taken inside it in this way. So as it is taken, okay, it's taken inside it. It forms another group. Fine. So two clusters are there, and finally take this group into it, and this whole combination of them is formed. Then where the clusters are now, wherever whatever number of clusters you want, you just have to stop over there, that particular point. For example, I want 3 clusters, So this is my ideal value of the clustering, ideal phase of clustering. I want two clusters, this is ideal phase of clustering here. Or I want four clusters, I want this is ideal phase, or this one. It depends upon the level that we generally choose. So this technique, this working is converted in the form of a tree, in the form of in the form of a hierarchy. And that's what we call as a dendrogram. See the dendrogram for this data, how it is actually created. Check it out. So I've given some numbers to them, like A, B, C, D, E, F. Okay, names are given. So, and now as you are connecting them together, so their levels of connectivity are set. Levels of the connectivity are set, and how these labels are there. So let's see this how these labels are identified. So first of all, E and F are connected. See the dendrogram for this particular data, I've given the names, numbers, sorry, values to them, labels to assign the name. E and F are connected first, these two. Okay, E and F. Then we connect A and B. E, F connected first at the lowest level. Then next to that, above it, we are connecting A and B. A and B are connected here. Okay. Then we are connected D to EF. D is connected to EF. D is connected to EF altogether, like that. This one. Okay. Then C is connected to DEF. This one. Okay. And finally, A and B, AB is connected to CDEF. Here. AB is connected to CDEF. Now, how many clusters you want? Just put a cut over there. How many clusters you want? For example, I want two clusters. So I'll have a cut here. So AB is first cluster and CDEF is another cluster. Fine. I want three, then I will have a cut over here. So AB in one group, C in one group, and DEF in one group. I want four. So I'll have a cut over here. So AB in one group, C in one group, D in one group, and EF in one group. This way. So treating every individual point as a separate cluster is done first, and then with the help of again some formula, some methods I'll show you, by which identifies which is the closest point, close, 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 and then combine them and form a dendrogram over there, which is just shown over here. Dendrogram drawing is also possible with the help of the library. I'll show you how to do this one. It's very easy to do. In our case, I'll carry forward the same data and then we'll convert that into hierarchical and we'll compare the results. The output that we have achieved from the clustering technique will compare and see whether same clustering is done or some different things are present over there. See that. Now, measures of distances. Measure of distances means between distance between two clusters, distance between 2 points, formulas are different. Okay, the distance between two points is different. So it uses some many different metrics also presented over here. Linkage criteria. What sort of linkage criteria we use? Yeah. So let's say this cluster and this cluster. This point and this cluster. Okay. Some distortion was there, I think. Now, okay, so how to calculate the distance? Distance is nothing but the point. So the point from where the distance is calculated. Average, specific point, boundary, the linkage criteria. For example, it can be computed using two most similar part of the cluster. That is called a single linkage. Similar part, the directly distance calculation is done. Called as complete linkage. Okay. The second criteria, complete linkage. Third is center of the cluster, called as the mean or average linkage. Mean linkage or the average linkage. Or some other criteria like things are mentioned here, distance matrix or Ward's method. So there is a formula that Ward's method is used. With the help of that also, the linkage criteria is found. What is the location to, what is the position to make the distance calculation, that is done with the help of this particular methods called as linkage criteria. So we have to mention that linkage criteria while applying the algorithm also. Linkage criteria are required to be specified in the code. Fine. So let's see. This is what we require. So when you, I'll show it actually how it is done. I'll show where the linkage criteria are required. Hierarchical clustering typically works by sequentially merging similar clusters. This is called as hierarchical or agglomerative clustering. Agglomerative. Merging is done there. In theory, it can also be done by initially grouping all the observation to one another and successfully splitting these particular clusters is called as the divisive clustering. See this. The two methods are present which we apply. General criteria is that k-means make use of a divisive clustering and hierarchical make use of the agglomerative clustering. Actually, k-means is not 100% divisive. Similar kind of things are created, like their way of clustering are differentiated by this kind of methods. Agglomerative separate groups are formed, and in divisive, you just can define the clusters already. So it's not starting from one actually. Okay, it's starting from specific value of k. Like I've given 5 previously, so it start from 5 onwards. 5 and take one by one, one by one inside it. Like from one, it is not started, but it's almost like that. Divisive k means and hierarchical is agglomerative kind of clustering, which is just shown over here. We can observe and identify. Okay, so in this way, that's the difference between the agglomerative clustering, hierarchical clustering, and the divisive clustering or the k-means kind of clustering. How they are taking the element group on what notion, what metrics, what criteria that they are following, that we have seen. And now let's see how we implemented that. I'll show the same means, for example, the data set that we have seen, same data set I carry forward, and because it will be easy for us to compare the results or the output which generated by this method, whether they are similar or the different or not. Okay, so anything, one extra thing I require for here, just from the previous example, I require a package called as scientific Python, SciPy. Scientific Python is required for dendrogram and the linkage criteria to use it there. Okay, so let me show. It is getting disconnected. Wait a minute. I'll share my code again. Let's see. Yeah. Let's apply. It's not that much complicated, or it will not take much time to create the hierarchical clustering over here, or show the dendrogram, or to show the predictions like that. Here we don't have centroids. We are having only distance matrices. With the help of that, we find the output over here. So let's read that. Just a minute. Let's check it out. We'll read your data frame in the code. Okay, so it's okay. And as we have seen, we don't require the whole data. I just have to focus on last two columns, that is column number 3 and column number 4, that will require for that. So I'll just separate them using, okay. So they are taken. Fine. So these two columns I just want to extract from the respective data set. Data frame is there. The X is the data frame actually. Once it's extracted, just get it out. Okay. So I'll show the dendrogram first. So basically, dendrogram of this is complex. 200 entries will be shown. That will be somewhat difficult to understand in that case. So what I'll do, I'll just you common dendrogram, simple dendrogram is actually created. Okay, so just a minute. Yeah, simple dendrogram I'll show first, and then we'll go for our application there. Now see, for example, I just created a simple database or some data set array, two-dimensional array of 10 elements whose name I've given X here. Okay, so X is just an array package of Python where arrays are created where it's compulsory you have same kind of the data inside it. Okay, and when I print this array, I'll just show you how this array looking like. See, this is the array created. Okay, and these are the points actually on the plane. Means just like you can see, observe this one. I have plotted them in this way. Okay, so X, this is your X, 0, that is contains 5, 10, 15, 24, 30, 50, like that. And column number 1, that is 3, 15, 12, 10, 30, 70, like that. Column number 0 and column number 1. These two are present inside it. I just want to plot them. Once you plot it, and then I'll show how the dendrogram is created for them. So by using the scatter plot, I have shown that one. On X side, I'll use 0th column, this one. And on Y side, I'll use column number 1. So this is how the basic plot is present. And I want to convert this data in the form of a dendrogram. So first of all, there's a function called a dendrogram. With the help of that, we just can assign the linkage criteria or the distance matrices. With the help of that, the dendrogram will be formed, and I can see that in the form of a plot. See this, it's shown scatter way here. Then from scipy.cluster.hierarchy, I have imported the dendrogram and linkage. These two, scipy.cluster.hierarchy, import dendrogram and linkage. These two are the functions which I'm importing. Then here the linkage criteria decided. It's called a single linkage, which I shown there. Single linkage. The most similar two points are connected. That's called a single. Then created a list which start from 1 to 10. Every point is assigned, should be assigned with a number. Okay. And finally, a dendrogram is generated for these 10 values, which is shown over here. 10 values, how dendrogram is formed. So here I'm creating a figure of 10 by 7. Then dendrogram function. Linkage criteria is single linkage applied. Orientation is given top. Okay. Then labels, which I want to assign to the root nodes, sorry, leaf nodes. It's a label list. Then which sort I'm using, descending sort. Show leaf counts true. And if I run this, can check this out. Yeah, PLT is not imported. And now let's see. Okay. Yeah, this is the dendrogram for the given data. See, dendrogram for the given data. So I think ideally 2 clusters are possible inside this data, which is randomly I have generated. So if I have a cut over here, this 5, 1, 4, 3, 2 will go in one cluster, and 9, 6, 10, 7, 8 will go in another cluster. Okay, on this. Okay, this is how dendrogram is actually formed. So dendrogram is defined by using default function in Python. SciPy package contain the dendrogram inside it, and with the help of that, I just can create a dendrogram. And just think of it: 200 entries are there, so it is filling the complete data. Nothing can be visible. So to just have demonstrate how dendrogram is looking like, this manual data I have created and then shown like that. So here in these two things are possible. So just if you see the output here, so this is one group and this is another group. This 5 element and these 5 elements. Easily directly on graph itself, we can observe that these two groups are possible on it. Okay, so all they will be given with the same number, and this will be given with the same number. Okay, like that is possible and present over here. So this is how the dendrograms are looking like. It's possible to have dendrogram first, and after that, let's see how to apply the hierarchical clustering and create your clusters separately on this similar data. So let's go to your original code. Sorry, not this. Here, and let's apply the clustering algorithms to this particular data set. Yeah. So you have read it, convert it. Now, first of all, we'll draw the dendrogram for this kind of the data. So I'll show the dendrogram for this particular data first, and then we'll go for. So let's see this. Okay. So two functions I require over here. Okay. And then simple figure. So I require a plotting function first. So by using that plotting, I can easily draw the dendrogram. So the figure size equal to 16 by 9. Okay. Figure size. And then let's have a dendrogram. Dent equal to dendrogram for the data that we'll be using here. So let's have to apply the linkage criteria. Linkage criteria for df for x, and the limiting method here is what's method. Let's see this. I have not used other parameter. Directly apply the data set to me. Whatever value I am having is applied to linkage criteria. Linkage criteria I'm using what's method, which was mentioned there in the slides also. So instead of using complete single average linkage, I can apply what's method also. It's a formula there by which the linkage is done. And now see this one. This is the dendrogram for your data set. See, it's the dendrogram. It's very complex actually. All of these names, numbers are shown over here. Okay. If you think about this dendrogram, if I made a cut over here, this one, so three clusters are possible, three for this case. And if I made a cut over here, so five clusters are possible. Okay, yeah. So whatever we have seen, five clusters, I'll carry forward the same concept. You have to create a five cluster for this data. So it's required to have a cut over here. So first cluster, then second, then this is third. I think 81 persons are present. It was there indeed. Then this is the third, sorry, fourth, and this is fifth. Five clusters. So directly within dendrogram also you can view that how many clusters are possible and where the accuracy is present, like this. Okay, so 200 things are present. Directly apply the dendrogram and you can observe how the dendrogram is looking like. So we have to mention the linkage criteria. You have to mention the values of the features as data has been put to that, and then the dendrogram can be visible, can be seen. So we require a matplotlib Python plotting library, basically the visualization library that is required, and it automatically will plot the dendrogram with the help of the respective function which is present inside the scipy. It's a scientific Python actually, which is very regularly used by the developers. Even in data science also it plays very important role to do analysis from different kind of angles. Okay. Scipy and NumPy, two libraries which we generally use over here. Okay, so like this dendrograms can be seen, and that can be used here. But remember, clustering is not applied yet. Now we have to apply the clustering. After the clustering is applied, then similar kind of labels will be generated, and that using that label I can visualize my clustering is perfectly done or not. So let's see. So from again, so again in this same package cluster, I'm having different kind of algorithms there. Out of it, one algorithm is sorry, import agglomerative clustering. Okay, agglomerative clustering. Agglomerative clustering is the name of the class whose object I have to create. And after that object is created, the same kind of methods are there that we have seen there in it. So here I'm not using any elbow or seal out method to find it. Even that can also be used. So you can make use of that method also here, but generally they are dedicated for k-means algorithm to find it. SSE is not present over here, remember. Okay, so let's check it out. So let's create the object of it, like hierarchical clustering, HIE. Okay, agglomerative clustering. Parameter that you would specify is number of clusters. Let's make number of clusters is equal to 5. And what distance matrix you have to use, that I can specify using affinity, Euclidean, Euclidean, and even I can specify the linkage criteria also here. So which linkage criteria you have to use? So let's use word. Yeah, it's mentioned there. Now done. Yeah, object of hierarchical clustering is created. So how many clusters you want? 5 clusters I want. By using which affinity means this your simple distance calculation method, Euclidean, and what linkage criteria to apply? Words criteria. So there also complete mean average can also be given. Okay, so my object is created, and now let's use of your methods like fit predict method. With the help of the particular method, I can identify the labels. So our 200 values, the labels can be assigned. So let's have labels is equal to hi dot fit underscore predict. Okay, fit predict on X. Labels will be generated now. Same case, object dot fit underscore predict that you assign, then labels will be generated, and check out the labels now. See, 3, 4, 1, 0, and 2. So these numbers are assigned to respective elements, all the 200 elements. These labels are assigned by making use of the hierarchical clustering. Okay, I just apply the labels to them. Labels are assigned, and with the help of that labels, again, it's possible to visualize your data. Okay, so this is how we are applying the particular method over here, and to see or to visualize your data, we'll be making use of the same method there. Okay, so these are the labels we got, and in hierarchy, I'm having some more property by which you can identify what exactly the elements are present, like what are the children. Okay, how the groups are connected together, we can identify by the children variable attribute actually. Along with that, I can find the labels. They are also present inside the same object. Even how many number of clusters already we have given. Number of leaves 200. Exactly, number of elements itself are the leaves. All elements are separated. That also we can see. But important part is the label that you have extracted. And now let's visualize the numbers which are given, or the clustering which is generated from it. It's similar to k-means or not. That also we can compare. Okay, so let's compare that. Let's visualize it. It's very interesting to see the visualization for this case also. So let's have plt dot x label. So from x side we are having the annual income, and y side we are having the spending score. Okay, and let's plot it. Plt dot scatter. Let's use a scatter plot from x. X is a data frame. Okay, fine. So all these and number 0. Okay, spending annual income on the x-axis, and just like that, y-axis is for the spending score. So x dot I log 1. Okay. So this is your original data, correct? So we have seen the original data already. It was just like this. Let's make it clear. See this. Non-clustered data. Fine. And let's go for the clustered data. So whatever the labels I extracted, means the cluster numbers, cluster labels are assigned there. I just can use it here. C is equal to labels. Okay. Now see. the clusters that we have seen over here are like this. Getting? And almost similar are there. He observed that they are almost similar kind of clustering is done, but there's difference actually. If you see this, if you observe that this is the output of hierarchical clustering, almost same we can see, but the difference lies on the boundary points, boundary points of the clusters. So wherever the boundary positions are there, they will have a some bit confusion. Let me show you. So let's go for previous case, and I'll just delete this part. Let's put it in comment. I'll say the output of k means first, and then we go for the hierarchical. Yeah, see this. Check this. This is the output of k means clustering. Okay, centroids are given. Hierarchy does not contain the centroids. See, just maximize it, and now see this. Boundary points problems are there. Now, if you observe these 2 points, see this one, yellow, and here the violet is there. Okay, this one, these 2 points on boundary points. But here, this point in first cluster, this is in second cluster. Okay, and if you go here, see this in hierarchical clustering, both are in the center point. This one, both are fine. Distance metrics are different. That's why it happens here. This is in center. But in case of K-means algorithm, this point is in first order. And you can observe these points also. See, there are 6 points present at this position here. This is showing, I'm showing for the hierarchical clustering, this one. 1, 2, 3, 4, 5, 6 are there. All 6 are there in the middle cluster. All 6 are there in the middle cluster. And if you go to check it here, see, out of this 6 in the K-means algorithm, out of the 6, 3 are in central cluster and 3 are in this purple cluster. Check this. How 50-50. So problem is there, or confusion actually there on the boundary position. So on the boundary point, which are not belonging to a specific cluster, which is on the boundary of 2 different clusters. So there we can have some confusion, some problems will be present there. But logically, if you think, we just can make use of any one of the algorithm which is feasible to in general case, the results of k-means clustering are used very regularly by different developers, because most accurate results are given by them. This is I shown over here. And some developer uses the hierarchy clustering also. Okay, so where we are having n different kind of elements present in the different clusters, so there is small difference can be there. Maybe the length of many clusters are same, but where on boundary multiple points are lying, so there will be a confusion. So if you consider about this part, so there is no any boundary, direct connectivity boundaries are there, so direct empty position, there's no confusion present here. Here we are having this, here we are having this, on this side also I think no much confusion. They are completely perfect cluster formed here also. Cluster is formed here. These 2 clusters are perfect actually, but here we have some problems in the boundary. Because why it happens? Because of different mechanisms which are used in the algorithm, different methods that we apply to perform the operations. Because of that, it may be possible that these values will change. Everyone's preference, algorithm preferences are different, criteria are different. Based on that, they uses the particular operation to do on the respective data point. That's why we are getting this kind of the difference over here. Remember, okay? So this is your hierarchical clustering, how we have applied it, how we have generated the result like this. And even same way we can do the predictions also. Okay, so if a new data point is coming and in which particular cluster it should go, so to separate the cluster perfectly, it's possible here in hierarchical clustering also. So we'll show you just new point is coming, was 37 and 73. Okay, 37 is the annual income and 72 is the spending score of the respective person. So to do this one, let's use HIE dot predict. Just another problem. Just a minute. Hierarchical clustering, it is not having this particular prediction operation. I need to combine it to the mixture, Gaussian mixture. That's why I can make use of. There is one more clustering algorithm used. Not that. The clustering algorithms are just I shown agglomerative k-means. I'll show one more kind of thing that we have to combine together, and then only it is possible to have the prediction for this kind of the clustering over here. See, so the algorithm which are used, they are taken from this particular function, this particular package called sklearn, and inside the sklearn I'm having a cluster method. So very different technique which are used for the clustering, they are already formed and available and present inside the cluster sub package there. And now let's see other methods. So if you want to use them, so you just can make use of them easily. I'll just check it out, just a minute. See, yeah, this is the official website of the scikit-learn. And here the clustering techniques are mentioned. Methods of all of them are almost same. You can just compare all of the clustering techniques. I'll just on the front page of them, they have given the differences of all. You can just observe it. See this. All clustering techniques are present. This is the comparison of all clustering. So I'm not connected only with the hierarchical. You can use others also, like k-means, which is the first parameters required, which are mentioned over here. Affinity propagation, mean shift, then word hierarchical, which we have used here. Agglomerative also. So here combinations are there. Spectral, DB scan, also one of the very commonly used clustering, DB scan. Optics, Gaussian mixture, perch. Okay, so the differences are shown, and in terms of the graph also, how the clustering is possible and present, that is shown over here. See, and wait a minute. Many things are present over here, how exactly it should be done. If you want more detail, more operation or more information about it, so just can go to this particular link, scikit-learn. It's an official website. Inside that you have to check for the clustering. So whatever the clustering techniques are present, all their information will be given by them. I'll show one more. For example, I want to make use of the Gaussian mixture, this one. Okay, if I click on that Gaussian mixture, I'll get information about it. I don't have to go in detail about how it's working, but if you want to directly apply that technique, so I can make use of it. Like, this is a package called as sklearn.mixture, and with the help of that, Gaussian mixture can be applied. Let's see how simple is that. And just see this. See what I'll do. So from sklearn.mixture, okay, import Gaussian mixture. Okay, create the object of it, just like same way. I'll just show is equal to Gaussian mixture, and number of components is here, not clusters actually. Okay, GM is created, then gm.fit predict. Now see, done. See, labels I got from Gaussian mixture clustering. Same, I just created object of it, number of components I want, and fit predict, I got the respective labels over there. And if I want to visualize, again, I can use the same method to visualize for this clustering technique also. So applied it, see the output. Here also we'll get a small difference there. I'll show you the output differences here. See, this is Gaussian mixtures output that we are getting out of it here. Gaussian mixture. If I compare with hierarchical, all 6 points are there in the center position here. Okay, and we have seen 50%, 15 k-means, and now see Gaussian mixturing. one point is in this cluster and 5 are in central cluster. Fine. This way. Okay, Gaussian mixture clustering. So the technique Gaussian mixture is applying is different. So there is a formula, or there's one more model that it's having that is applied, and based on that the clustering is formed, and you can make use of it. These are commonly used technically. Some algorithm work on spatial kind of the data, spatial kind of like DB scan is just called is a density based. So clustering is done over there. If you want to apply, so DB scan can be used, or even there is one more clustering called as a fuzzy technique is used there. Fuzzy C means uh, clustering, which is used to perform, and fuzzy logic is used to get the data into that particular clusters. Okay, so like that. So in this way, we can make use of the clustering technique. Just I'll continue with my presentation. Yeah, fine. So this is the way that we apply the clustering techniques, and we can make use of this technique to create the groups within your data by making use of different ways that we generally follow. See, just statistics, I'll just show you. Predictive analytics and descriptive analytics, as I told, two different methods are present in the machine learning data science by which you do the predictive and descriptive analytics. Predictive analytics is almost done in 78% algorithm. This is the actual survey. 78% algorithm predictive analytics are doing, and the remaining 22 are doing descriptive analytics. Means 22 are using only unsupervised learning, and many algorithms are there. More than 50% algorithm are making the combinations, okay, of both clustering also and classification, or in this supervised learning also. That's depend on the data set that you're going to make use of, and depend upon the problem that you're going to solve, that you're going to make use of it to perform the further operation there. Okay, this is what the clustering techniques are. Okay, so that's from my side. If you're having any kind of questions or doubts, so you're open for that. Thank you. Thanks a lot.
Thank you, sir. So we have a few questions.
Yeah.
The first question is how to validate the clustering results using Python.
Okay, validation. See, there are some matrices are used in sklearn. Also, I'm having one method. Basically, every cluster technique is having their own mechanism. So basically, just like using classification and clustering, we you do train test split, classification regression. Sorry, train test split and validation are done, and then we check that whether our data is matching over there or not, and based on that, the operations are performed. See, here we can make use of one technique called as the semi-supervised learning. Generally, I use over there semi-supervised learning. What we have to do in semi-supervised learning? Semi-supervised learning contains some part clustered, some part labeled and some part unlabeled. So what we generally do, we just make use of a train test split operations there, and out of it, we some labels are deleted randomly. Some labels will be deleted out of it. Some labels are deleted whose labels are already present with us. Okay, we apply a clustering technique, and once the clustering technique is applied, again new labels will be assigned by the semi supervised learning. Okay, new labels will be assigned to them by looking at, for just an example, number 1 and 3 are labeled but 2 is not labeled. 1 and 3 is labeled but 2 is not labeled, means some part are labeled, some are not labeled. What we intentionally do, we take that 2 out of it by using random validation, by using random selection of it, and by applying clustering technique, we check that the previous cluster which are applied and the new technique that we are applying, they are perfectly same or not. So generally semi supervised learning techniques are applied there. Two algorithms are there which are used in semi supervised learning, that we can make use of it. And even in sklearn, some validation methods are used, but I don't think that these validation methods are perfect, because every clustering is different, your expectations are different, and based on that you can choose your algorithm over there. Some validations are there, but in general my case, I make use of a semi supervised learning. With the help of that, 50-50 or some 75-30 kind of labeled and unlabeled samples I'm using, and based on that I identify that which algorithm is giving perfect results and which algorithm is not giving the perfect results.
Okay, thank you, sir. Next question is, when can we obtain few data sets for experimentation?
When?
Where can we
Where?
obtain
Okay, okay.
few data sets for experimentation?
Just a minute. I'll show some links there. Okay, those who are working in data science, okay, they might be already knowing about this. Have you heard about the UCI machine learning repository? I'll show the slide here. Just a minute. So generally, I use that. Huh, yeah. Hmm. So this is actually Kaggle. Okay, so where we can get it, and one more which I regularly use called as UCI. Check this. So here we can separately access the data for different problems. See, okay, this is UCI machine learning repository, UCI Irvine. Maybe almost every data scientist uses this for the operation. So if I want to use some data set, if I click on this view data set, and you can check it out, default task mentioned there. These are the data set names. Almost 559 data sets are present over here, and all are standard. Okay, and for what operation they are done, so you can default task is given: classification, recommendation, regression. See that classification here. You can find data sets are available for clustering also. See, sorry, it's not shown still. Very less number of there for clustering. Yeah, see this one. Clustering. This is for clustering. This is clustering. So UCI machine learning repository is a standard that we can use there. Almost all data are validated, and these data sets are used in research paper also. Means if I click on that, you just can check below. See here the research papers are given. Paper which are citing this data set, which are cited this. All the research papers. Every data set which is used in the data is a research paper also. So this is the good site that we can use, UCI ML repository. And if you want to go for local repository, local means anyone can upload, anyone can download. Kaggle.com. There also you can see. Along with that, I'll show one more. It's called as Quandl, QUANDL, where data set related to finance can be seen. And one more is there called as data.world, WRLT, world. Okay, data.world. Here also you can see many data sets. Data.world, this one, see this. And here, this is Quandl. Most powerful data lives on Quandl. They are saying, so you can use this one also. Okay, so there we can obtain the data set for your experiment. Almost many different data sets are available. Even you can make use of GitHub also. On GitHub also many open source projects are available. They are giving data set along with the open source projects also. Fine.
Yeah, thank you, sir. With this, we are at the end of the session and will conclude with vote of thanks. I, Pranav Chakraborty, on behalf of the SPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, heartily thank Tushar Kute sir for focusing on clustering and predictions in machine learning and making things clear. I heartily thank him for sparing his time and sharing his experience with all. Thank you, sir. Thanks a lot. With this, I declare the end of session. Thank you all for participating. See you at 2 p.m. in the next session. Thank you, sir.
Thank you. Thanks a lot.